In this video, we'll look at the Heathkit IT-17 tube checker. I'll start with a discussion of what tube checkers and testers are and how they work. I'll briefly mention the Heathkit company and their products and history. Then we'll look at the IT-17 running through its features, the front panel controls, and see a demonstration of testing some tubes of various types. I'll describe where I acquired this unit and the work done to restore it. Finally, I'll give a few references to more information on tube testers, Heathkit, and vintage test equipment. At one time, tube testers could be found in almost every drugstore in North America. The average person was capable of taking tubes out of a radio or TV, testing them at the drugstore, and replacing them if they tested bad. When electronics went all solid state, this became a thing of the past. Because tubes had a limited lifetime and were relatively expensive, they were designed to be easily replaced. A tube tester could determine if a tube was functioning or not. The consumer tube testers were large and provided storage for selection of new tubes. Tube testers were also sold that were aimed at engineers, manufacturers, radio and television repair technicians, and hobbyists. Essentially, there were two major general types of testers. Vacuum tubes rely on an effect called thermionic emission, where electrons can flow in a vacuum when emitted from a heated element called a cathode. The heating is performed by an element called a heater, which is similar to a light bulb filament. The most basic testers can do an emission test that verifies that current can flow through the tube. On all but the very lowest cost testers, a meter usually gives some indication of the level of emission. Most testers also test for shorts between the elements. Typically this is done first before an emission test. This type of tester is usually referred to as a tube checker. Some tube checkers were even simpler and only tested that the tube's heater filament was not open. Most tubes can amplify a signal. A measure of the tube's ability to amplify is known as its transconductance. A more sophisticated tester can measure the tube's actual transconductance value. Because of the complexity of doing this, most testers perform a simplified version of this test, often calling it some similar term such as mutual conductance or dynamic conductance. The switch settings for testing a tube typically came from a roll chart, which was integrated into the tester. Over time, the roll charts were regularly updated to correct errors and add new tube types as they came on the market. Companies that sold tube testers, including Heathkit, typically offered yearly subscriptions for updates to the roll charts for a fee. In old tube-based equipment, a bad tube is actually one of the least likely causes of failure. Unless a tube is physically broken, much more likely problems are electrolytic capacitors, leaky wax paper capacitors, or carbon resistors that have changed value. After all these years, tubes are still available, both used and what is referred to as NOS, new old stock, old tubes that have never been used. Some tubes are still being manufactured in Russia and China for markets like electric guitar amplifiers and amateur radio transmitters. There are only a few tubes that are now hard to find. Heathkit was a manufacturer of electronics in kit form. Their product line included amateur radio, test equipment, and various consumer products. By building a piece of electronics, you could save money and gain the satisfaction of having it assembled it yourself. Heathkit sold a number of tube checkers and testers, starting with the TC1 in 1949, and followed later by TC2 and TC3 models, which were very similar. Later units followed Heathkit's more standardized product naming scheme, the IT-21, IT-17, and IT-3117. The company Weston made respected tube testers, and for a period of time both Heathkit and Weston were divisions of the Daystrom company. The Weston 981-3 mutual transconductance tester was adapted to become the Heathkit TT1, a more sophisticated tester than the earlier models. To test picture tubes, Heathkit provided an adapter for some testers. They also made some dedicated tube testers for CRTs or picture tubes, often called rejuvenators, as they could sometimes fix shorts or improve the performance of old tubes. The Heathkit IT-17 tube checker was offered from 1967 to 1976. It was relabeled as the IT-3117 in 1977 and sold until 1981. The 1971 catalog lists it at $54.95, and it was selling for $99.95 in 1976. It was only offered as a kit. This is an emission type tester built as a tube checker rather than a tube tester, where the tubes are tested for merit by connecting all the grids to the plate, operating the tube as a rectifier, and comparing the current flow to a predetermined value for the tube type, indicating the tube as good or bad on a meter. Typically, Heathkit also offered a more expensive mutual conductance type tester at a higher price. In 1971, the TT1A mutual conductance tube tester on the same catalog page as the IT-17 was selling for $179.95. Like most tube testers, settings for testing specific tubes are listed on a roll chart contained within the unit itself and visible through a window. To accommodate new tube types, Heathkit offered a tube chart subscription service, either single charts or a subscription of 2 supplements per year. In 1971, the cost was $3.50 per chart or $5 per year. Apparently, this was handled by a third party, as the catalogs list an address in Long Island, New York to contact rather than the Heath Company. The roll charts were compatible between some testers from other manufacturers, so you could potentially use the same roll charts, in some cases changing numbered levers to corresponding letters. The IT-17 has sockets for 12 different types of tubes. Early 4, 5, 6, and 7 pin tubes common in the 1920s and 30s, like this number 27 globe-shaped triode. Small 5 and 7 pin new Vistor tubes common in the last of the tube-based television sets. I don't have any of these. 8 pin octal tubes made from metal or glass and sometimes having tube caps. These were common throughout the 1940s. This clip is used to connect to a tube cap, if present. Seven, 8, and 9 pin miniature tubes, all glass. These were common from the 1950s until the end of the tube era. 8 pin Loctite tubes. These were originally designed to withstand the vibration encountered in car radios without coming loose. 12 pin compactrons, which contain multiple tubes and tried to compete with transistors. I don't have an example. A switch selects the filament or heater voltage in 20 steps from 0.63 volts to 110 volts. The control sets the plate voltage used for testing, marked from 0 to 100. The type switch selects the range of test voltages used, one of 30, 100, and 250 volts AC. The set line switch controls power and calibrates the unit to compensate for changing line voltages. A meter indicates the performance test result, marked with bad, question mark, and good, as well as numbers from 0 to 100. A switch selects between short and leakage testing, and another switch between line adjust and tube test. The roll chart appears in a window and is controlled using 2 thumb wheels. 13 3-position switches control the connections between the tester and the pins of the tube under test. Tubes with up to 12 pins as well as a tube cap can be tested. It's portable, the roll chart and meter are illuminated, and the unit weighs about 9 pounds. The manual covers the different types of tube testers and why emission testing, like this one, is a good trade-off between test accuracy and the cost and complexity of the tester. With sockets for 12 different tube types, it was better than some competing testers which didn't support as many different types of sockets. Here's a view inside the unit. The circuit has only a few components, mostly switches and wiring. A power transformer has taps for all the filament voltages and high voltages. Other components include the neon lamp, 1 milliamp meter, and a handful of resistors and capacitors. The wiring harness came pre-assembled and color-coded to make assembly easier. A vacuum tube voltmeter was recommended for testing the assembled unit. Let's run through testing some tubes. The tests performed include shorts, leakage, quality, opens, and filament test. The meter is calibrated in arbitrary units from 0 to 100, with sections indicated as bad, questionable, or good. Let's start by testing a 50L6 octal-based tetrode, common in all American 5 type AM radios. The procedure for testing is as follows. Turn the unit on and set the line control until the meter reading is within the line test block. This compensates for varying AC line voltage. Find the tube type on the roll chart. So here it's 50L6. Set the type switch as per the roll chart. Here it's type 3. Set the filament selector to the voltage listed in the roll chart. In this case, 50. Set the plate control as specified in the roll chart. For this tube, it's 21. Set the lever positions to T, top, or B, bottom, as per the roll chart. For this tube, the top switches are C, D, and E, and the bottom at G and H. Connect the test clip to the tube grid cap if applicable. It's not for this tube. Insert the tube in the appropriate socket. And readjust the line test if needed. We start by performing the shorts test. Move the levers indicated on the chart in light type between the indicated positions and center. The short leakage switch is set to short. A steady glow of the neon lamp for any switch setting indicates a short. This tube looks good. Perform leakage test. Repeat the above step, but with short leakage switch set to leakage. And an illuminated lamp will indicate leakage. Again, this tube doesn't fail. Now the quality test. Move the slide switch to the test position. The meter will indicate good, bad, or questionable. In this case, the tube shows as good. Opens test. With the switch in the test position, move levers that are at the top to the bottom position and back. You should observe a decrease in meter reading. If not, the corresponding tube element is likely open. So this tube looks good. And finally, filament check. Set the filament selector to 0.63 volts. Move the levers listed in dark type through the other two positions. The short indicator lamp should light if the filaments are okay, as it does here. If the tube fails the shorts or leakage test, it's usually considered bad and the quality test is not performed. For multiple tubes, such as dual or triple tubes, multiple tests are listed on the roll chart in brackets. In this case, you repeat the test for each bracketed list of settings. Let's test another tube, in this case a 12AX7 dual triode that's still manufactured and is popular in electric guitar and audio amplifiers. This is a multi-element tube that has two sets of tests to run. So we find the tube on the roll chart, 12AX7. Type is 1. Filament voltage is 6.3. Plate voltage is 20. Top levers are A and B, and bottom C, D, and E. So insert the tube in the miniature socket. So we perform the shorts test with levers A and B and C. Looks okay. And now repeat again for leakage. And now for the performance test, and the tube looks like it's good. Let's skip the open test and filament test. Now this is a multi-element tube, so there's a second set of tests to test the second element, the second entry in the roll chart. For this one, again, the type is 1, filament voltage is 6.3, plate is still at 20, but the lever settings are now top F and G, and bottom D, E, and H. So checking for shorts. And leakage. Looks good. And now for the performance test, and again it's reading good. Here's a handy little feature. You can test a lamp using the center of the 7-pin socket. Set the filament voltage to the appropriate voltage for the lamp. Here's a number 47 bulb, which runs at 6.3 volts. If a tube's not listed in the chart, you can follow the generic instructions in the manual given the tube's base diagram. You need a known good tube of the type, or preferably at least 3, to determine what plate control setting is needed for a good tube to show in the middle of the good range. I purchased my IT-17 from a local seller on Kijiji. It was reported to be working fine. I gave it some cleaning and a full checkout. The only modification I could see was that at some point someone had repainted the back of the case in a brown color. I found a partial manual on the internet as well as a newer roll chart than the one it came with. In testing this unit, I had problems with octal tubes. They all showed as bad and the filaments did not light up. I discovered that the wiring of the octal tube socket was wrong. All wires were offset by 1 pin. That means that the tester could not have worked for one of the most common types of tubes. Presumably the unit would have been like this since it was assembled probably sometime in the 1960s or 70s. It goes to show that you can never make assumptions when working on old kits. I rewired the socket and it then worked correctly. The book Tube Testers and Classic Electronic Test Gear by Alan Douglas discusses tube testers in more detail and describes the models offered by all the major manufacturers, including Heathkit. My new book, Classic Heathkit Electronic Test Equipment, covers Heathkit's test equipment products, starting with a brief history of Heathkit, an overview of the test equipment product lines, and tips on buying and restoring vintage test equipment from sources like eBay. Separate chapters cover the major categories of component testers and substitution boxes, frequency counters, meters, oscilloscopes, power supplies, signal generators, tube testers and checkers, and miscellaneous test equipment. Each chapter includes one or more in-depth sections that looks at a representative model from my Heathkit collection, covering its features, operation, and notable quirks or trivia. The appendix provides a list of references and resources including books, websites, and suppliers of parts, manuals, and related products and services, as well as a detailed product listing of every known model of test equipment produced by Heathkit. The book is available from lulu.com and retails for $19.95. Getting back to the drugstore tube tester, it's sometimes said that the purpose of tube testers was to sell tubes. It's claimed that often the drugstore testers were calibrated so that many tubes would test as questionable or weak to get the customer to purchase a new tube. Because most tube testers don't measure true transconductance, they only give an approximate result. The best test for a tube is in the circuit it runs in. Don't throw out a tube because it reads weak on a tester. It may work fine in a radio. Discard it if it is physically broken, has a burnt out heater, or shorts. And even shorts are okay in some cases if the elements are not used. The Heathkit IT-17 is a good example of a mid-range tube tester that was popular with hobbyists and service shops. Because it was sold as a kit, it was lower in cost than similar assembled commercial products. I have another YouTube video on a similar tube tester, the ICO Model 666. Thanks for watching. I hope you enjoyed this video. Watch for my other videos on vintage radio and test equipment.